This is a brief introduction into right triangle trig. You should know right triangle trig, but this will be a review over it. Remember that in right triangle trig, we can use the acronym SOHCAHTOA to help us remember the three trig functions. Right triangle trig involves right triangles. And then this right triangle here, we're going to label our sides as side A, B, and we'll let the hypotenuse be C. From this, if we go through and label the actual sides with words, we get side B as being the opposite side, or let's mark an angle actually. So here is angle B across from little b. We have A across from little a, and we'll let the right triangle or the right angle be side length C across from the hypotenuse. If we label our sides with respect to this angles now, and we'll mark angle B. Let's talk about angle B here. With respect to angle B, this is the opposite side. And with respect to angle B, the side that B sits on is called the adjacent side. And the side across from the right triangle is always going to be our hypotenuse. So we can go through and now label it using these labels for the sides. We can say that the sine of angle B is equal to its opposite side over the hypotenuse. In this case, our opposite side is B, and we'll call the hypotenuse C, so that's B over C. We'll say the cosine of angle B is equal to its adjacent side over the hypotenuse, or in this case, that would be A over C. And we'll say that the tangent of angle B is equal to its opposite side over its adjacent side, or in this case, that's B over A. Realize that if we switch angles and talk about A, all of these ratios will flip. So this is really about respect to whatever angle you're talking about. So the first thing you should do with any right triangle is mark the angle and then label the sides. So let's do a few examples. Look at example 1. Find the trig ratios for sine x, cosine x, and tan x. So they're telling us to mark angle x first. So let's mark angle x up here. That's the angle of interest. And then we'll label the sides with respect to x. So we have this side is the opposite side. The side that x touches is the adjacent side. And the side across from the right angle is the hypotenuse. Now notice, to write the trig ratios, we need to have all three sides. Here we're only given 2. So we're going to use Pythagorean theorem to find the third side of a right triangle. And we have this 5 squared plus, we'll call this side across from x is little x, so we'll call that x squared is equal to hypotenuse squared. So we have 25 plus x squared equals 13 squared is 169. We'll subtract 25 on both sides, and we get x squared is equal to 144. Take the square root of both sides, we get x equals 12. So we know our missing side over here, x is 12. We can go ahead and write out the actual functions now. We know that the sine of x is equal to its opposite side, or 12, over the hypotenuse, which is 13. We know that the cosine of x is equal to its adjacent side, which is 5, over its hypotenuse, which again is 13. And we know the tangent of x is equal to its opposite side, which is 12, over the adjacent side, which is 5. And so here are all your angles, or here are all your side lengths, and we found all the ratios by first finding that missing side and then labeling the triangle. Look at example 2. It says find the measure of angle D in the figure. So we know we're going to mark angle D, which is sitting up here. Marking angle D, which sits here. And again, we're going to label our sides. So go across from angle D. This is the opposite side. This is the adjacent, this is the hypotenuse. And this time we don't have to really find the missing sides. We're trying to find an angle. So using the information that's given to us, what function involves opposite and hypotenuse? Well, that function is going to be the s function, which is O and H. So this tells me I need to use the sine function to get here. And so what we do is we're going to do the sine of angle D is equal to its opposite side, which is 9, over 13. So using this trig ratio, we need to go ahead and find an angle. When you want to find an angle from a trig ratio, you have to use your calculator, and you have to use the inverse function. So we know that D is going to be equal to the sine inverse of 9 divided by 13. So in a calculator, make sure the mode is set to degrees. And once your calculator is set in degrees, you're going to go find the sine inverse function. And it's the button that it should be right above sine. Normally you have to access it by pressing the second or a shift key. So press your second key, sine inverse, and do 9 divided by 13. And that's going to give you an angle measure of approximately 43.8 degrees. So pause the video and give example 3 a try. So in the example 3, it tells us find the measure of angle R. So again, we're going to mark angle R, which is here, and we're going to label our sides with respect to R. So again, this is the opposite side, and this is the adjacent side. So based on the information that's given to me, I want to find the measure of angle R using the opposite and adjacent side. I'm going to use the tangent function. T involves OA. So the tangent of angle R is equal to its opposite side, which is 8, over its adjacent side, which is 7. And again, to find the measure of angle R, we're actually going to do tan inverse of 8 divided by 7. And this is going to give us the value of R, the angle. So we do second, and above the tangent key is inverse, the tan inverse. 8 divided by 7. We get a measure of 48.8 degrees. Now, look at example 4. Let's find the missing value. So here you're given the angle 40. And they want you to find H, which is across from the right triangle. So this is the hypotenuse you're looking for. Well, you're also given this side length 18. With respect to this angle 40 is the opposite side. So you have the side lengths opposite and hypotenuse. That means you're going to use the function sine here. And we know that the sine of 40 degrees is equal to its opposite side, which is 18, divided by its hypotenuse, which is h. This right here is a cross multiplication problem. We put sine 40 over 1, and we're going to cross multiply and solve for h now. So when you get this, going through the math, it looks like this. H times the sine of 40 is equal to 18. Solving for sine 40, or solving for h, we're going to divide both sides by the sine of 40. So we get h equals 18 divided by sine 40. You plug this in your calculator, you get a value of 28. So the h value, or this hypotenuse, is 28, looks like centimeters. You give example 5 a try now. Pause the video and come back. So for this problem, they give us this angle 15, and we go here to x, we have the opposite side given to us, and then we want to find the opposite side, but the value that's given to us is the side that the angle sits on, so that's the adjacent side. So the function that involves opposite and adjacent again is going to be the tangent function. And so we have the tangent of 15 degrees is equal to its opposite side, x, which is what we want to find, over the adjacent, which is 25. Again, this is just cross multiplying. So here I get x equals 25 times the tan of 15 degrees. We plug in the calculator, we get a value of 6.7, whatever that unit is, so 6.7.